So, good afternoon, everyone. Myself is Dr. Ajit Kumar, and I'm faculty in the Department of PCE at Presidency University. So, in the last class, we were discussing about the interfacing of the memory chip with the microcontroller. We'll continue our uh, lecture for the same topic. So, we will continue our lecture for interfacing memory chip. Okay, as we have not done it in the last class, completed. So, interfacing memory chip with 8051. Okay. So this is the topic that will continue here. Fine. So see here, before again, discussing about our practical 8051 connection with the memory chip, we'll try to understand something that is called unused address line. Okay. So suppose, let's say, in the last class we have studied that our 8051 microcontroller. Okay. Actually, this is our 8051 microcontroller, and let's say here we have memory chip. Okay, so this memory chip, we know that this PC register is actually 16-bit register. 16-bit register. Okay, so if it is 16-bit register, so what is the significance is, and we know that the PC register holds the address. Okay, so we see here we have different locations here, and each locations are having different addresses. Okay, like this. So if I start from the lowest address, okay, so it will be 000H. Why? Because see, PC points to the address here, okay, and address size is 16 bit, okay, 16 bit. Right. And because we also know that address bus size is 16 bit in 8051. Okay, so now the question, now thing is, let us designate the address bus by something like A0, A1, A2, A3, A4, A5, A6, A7, A8, A9, A10, okay, A11, A12, A13, A14, and A15 because it is starting from A0, so it will go up to the last bit A15. So these are the address lines. Okay, so assume that they are address lines, or you can say address bits. Fine. So I can assign this hexadecimal. Okay, this is actually equals to 16 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this 0 is equivalent to this 0. Okay, similarly, this 0 is equivalent to the 4 zeros in the binary because we know they are the hexadecimal numbers. So this will be so 1, 2, 3, 4, 1, 2, 3, 4, and then this is up to here. Then 1, 2, 3, 4, and then 1, 2, 3, 4. Okay, like this. So the starting address will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So let us say that here I am having those address lines. Okay, A0, A1, A2, okay, A2, then A3. I mean, this is actually not practical. I'll show you that they are actually connected from the ports. Okay, port 0 and port 2 are used for the address lines and data lines. But for the sake of explanation, I'm giving this P, okay, directly here. Okay, that is A0 to A13, A4, A4, A5, A6, A7, A8, A9, A10, A11, A12, A13. Okay, so let us say A14, A15. Okay, so let us say that these are the address lines of our 8051. Okay, like this 7, 8, 9, 10, 11, 12, 13, 14, 15. Fine. Now, what is the thing is, if you see, okay, see here, these were the starting address. Okay, so the starting address is this one. Similarly, the next address will be 0001H. Okay, that is One is written from this one. This okay. This hexadecimal one is equivalent to 0001. Okay, this 4 bit. Then this 0 is equivalent to another 40. 1, 2, 3, 4. Then similarly this 0, okay, this is equivalent to 4 zeros. Then the last NSP 4 bits is 0000. Likewise, another higher address will be 002H. Okay, so 2 is written as 0010. Okay, and then similarly, all these bits will be 0. Okay, likewise, the last address, the last address will be actually the last address will be it will keep on going. Okay, 0010, then 0011, then this 0123, then 4 is 0100. Okay, these are still zeros. Like this it will go, and the last address will be all the binary ones. That is A15 as 1, A14 as 1, okay, A13 is 1, and like this we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, this is the last address. Now see here, this 4 ones, okay, this 4 1 is equivalent to F in hexadecimal. This 4 1 is again equivalent to F in hexadecimal. This 4 1 is equivalent to another F, and similarly the last 4 1 is equivalent to F. So this is the last address. Last address. This is the first address. In hexadecimal 1, 2, 3, 4 H. Like this. This is the first address. So I'll write here. Let us say that our lowest address is starting from the bottom and going to the highest address at the top. So this is the last address. Okay, the address of the last location. This is the last location. Now what is happening is all these address lines will be connected to the memory to transfer the address. Okay, like this. And so on. This is our address list. And there is also data line which is I'm just showing using this. Okay, this is data line, data bus, which is bidirectional. And one is control bus. You can assume control bus somewhere. Okay. Now thing is, if uh, if each location can store 1 byte, okay, 1 byte storage, then total storage is equals to number of location into 1 byte. So that will be actually 64K kilobytes. This is the total capacity of the memory chip that can be interfaced with your 8051 microcontroller. Fine. Now let us say, okay, so this is the total memory chip capacity. Okay, recall, I mean, just keep this in the mind. This is the total memory chip capacity when I'm using all these address lines. Okay, I'm using all the address lines. All these address lines are used to connect directly here. Okay, but the question is, suppose that I have not, I'm not going to use this full memory chip capacity. Let us say that our 8051 is connected with something, let's say 1 kilobyte. 1 KB is the memory chip capacity. I'm not connecting 64 kilobyte. Okay, I'm not connecting 64 kilobytes of memory chip. I'm connecting this memory chip whose capacity is lesser than 64K. Okay, now just see here, if this is the memory chip capacity, okay, this is the capacity of the memory chip, then can you say me that how many address lines will be required? How many address lines will be required? to interface with it with your 8051 microcontroller? How many address lines will be required? So this is the question. Okay, if you understand this concept, then you will be able to answer the question. Okay, of course, appreciate the concept of interfacing here. See here. Uh, okay, just see. I'll give you this number of address line using this memory chip capacity. Okay, so you do one thing. Uh, so let us write this 1 kilobyte. 1 kilobytes. Okay. Now try to write this 1k in the power of 2 to power n. Okay, so because if you recall, we have seen that why I'm saying in the power of 2, suppose this is your microcontroller, any microcontroller, this is your memory chip. Okay, if I am having a 4 locations, so for 4 location, you know, there will be 2 bit, okay, which we are used to assign the address. Okay, and for that purpose, you will need 2 address lines, that is A0, A1. Okay. Similarly, if you have this microcontroller interfaced with little bit larger memory chip having 8 locations. So 1, 2, 3, 4, 5, 6, and then 8. So you know that you will need here 3 bits to assign the address. Okay, this is where the address is here. So for this memory chip, okay, you need 3 bits, that is 000, 001, and 0010, then 011, that is 3, then 4 is this, then 5 is, then the 6 is, and then 7. These are the 3. So I need here 3 address lines, A0, A1, A2. Okay, A0, A1, A2. Okay, like this. So this is actually the case. Okay, now what is my point is, suppose that 1 byte of data will be stored here, 1 byte here, 1 byte here. Okay, 1 byte, 1 byte, 1 byte, 1 byte, 1 byte, 1 byte, 1 byte. So total memory chip capacity is total capacity. Total capacity is uh, number of locations, number of locations into number of bytes. Okay, number of byte is always 1 byte in each location. So I'll say 1 byte. That is number of location is 8, so it is 8 byte. This is the memory chip capacity. Now, if you try to go reverse means if suppose that this memory chip capacity is given and you are asked to find the number of address line, find the number of address line, address lines required to, okay, required to connect with microcontroller. Okay, so there is a way to find this one. Okay, what is that way? You write this 8, that is total memory chip capacity, okay, in the power of 2. So can I write it like this, 2 power 2 power 3, 2 power 3 bytes. So this, okay, this suffix which is coming as power is actually the number of address lines required, number of address lines required. Okay, so remember, okay, that you have to find 2 power n, okay, where n is the number of address lines. Okay, n is number of address line. If you want to confirm them, your same formula, so you can see this case also, that suppose that 1 byte of data is stored here, 1 byte, okay, 1 byte, 1 byte, okay, and there are 4 locations, so there will be 4 byte of memory chip capacity. Total capacity is 4 bytes. Okay, so in this case, 2 power 2. So 2 suffix is actually the number of address line, and I can see it is correct. Okay, I need here 2 address line. Okay, so in that same context, come back to this case. Okay, there I'm discussing for this case that suppose for 8051, whose PC is your 16 bit. Okay, so in that case, suppose that I have connected 8 kilobyte, not the 64 kilobyte. 64 kilobyte is the maximum memory chip capacity that can be interfaced with 8051. Okay, so you know for 1 kilobyte, okay, so 1K is 1024. Okay, and write this in power of 2. So 2 power 10. Okay, this is the total memory chip capacity. Now this suffix 10 is actually the number of address lines. Number of address lines required to connect with the 8051 microcontroller. But however, remember in 8051 microcontroller, there are total 16 address lines. Okay, A0, A1, A2, okay, so A9 and then A10, A11, A12, A13, A14, A15. So let's say this is up to here. Okay, okay. Now, so now the thing is, this memory chip need only 10 address lines. Okay, this memory chip needs 10 address lines. 10 address lines. So 10 address lines means A0 will be connected. Okay, A0 will be connected with A0 of your memory chip. Okay, A0, sorry, A1 address line will be connected with A1 address line of your memory chip. Similarly, A2 will be connected with A2. Okay, and the last is A9 because A9 will be connected with A9. Okay, so you can see A0 to A9, that is total 10 address lines. 10 address lines now utilized as per this memory chip capacity. Okay, the question is then where will be the rest of address lines be connected here? Okay, these in A10 to A15 are unused address lines. What to do for this one? So these unused address lines are actually connected with address decoder circuit, and the output of address decoder circuit is connected with CS pin. CS pin is chip select. If you remember in the last class, we talked about this concept chip select. If so, I told that if CS bar is 0, okay, it is input pin. So if 0 is sent from microcontroller to this pin, then your memory chip is selected. Then this memory chip is selected and then the processor will be doing read or write operation with this memory chip. Okay, fine. Now the thing is, these unused address lines are connected to address decoder circuit. Let's say that this address decoder circuit can be designed using any logic gate that you have studied. For example, AND gate, OR gate. Okay, so I let me use the OR gate here. Okay, OR gate, OR gate, okay, OR gate as address decoder circuit, as address decoder. So what I'll do, I'll connect one OR gate here. I'll connect one OR gate. The output of this OR gate is connected to this CS pin. Okay, with the CS pin. Fine. So the output of this OR gate is connected to CS pin, and all this input A10, A11, okay, that is A10, A11, then A12, A13, A14, and A15. Okay, A15. They are connected as input to this OR gate. Fine. Now what is happening is when all this, you know that what is the logic of OR gate? You know the logic of OR gate. Suppose A and B are the input, Y is the output. Okay, so you know 0, 0, 0, 1, 1, 0, 1, 1 are the inputs. Okay, so let's say this is OR gate. A and B are the inputs, and Y is the output. So you know if all the inputs are 0, the output is 0. If any one of the input is 1, then the output is 1. Now you have to focus on this one. Okay, what I need here, I need output 0 because if 0 is given by the microcontroller, then only this chip will be selected. So I need here 0 at the output of OR gate. So the correspondingly, what is desired input? What should be the desired input? I need all the inputs should be 0. A10 should be 0. Okay, A10 should be 0. A11 should be 0. Likewise, A15 should be 0. If all the inputs are 0, then only your output will be 0, and then this chip will be selected. Okay. So this is the logic that what we do here is we connect the unused address lines. Okay. So the unused address lines are connected. Fine. The unused address lines are connected. So what is my point is unused unused address lines are connected as inputs to address decoder circuit. Address decoder circuit. And and the output of address decoder is connected as input to CS pin of memory chip. So remember this concept. Okay. Okay. Now one more thing. Uh, so here, suppose let us take again this example. Okay, that where we have connected this one. Okay, this example. Come back to this one. Come back to this case. So in this case, can you see when all the three address lines were connected, that is A0, A1, and A2 directly to the memory chip, then the last address was 3 ones and first address was 2 ones. Similarly, when we had two address bus, the first address was 00 and the last address was 11. Okay. Now, this is called range of address. This is called range of address. Range of address. Okay. So, what is to be noted here is if you connect directly all the addresses 1, 2, 3, then the range of address is all zeros to all ones. Okay, that is 000 to 111. This is called range of address, minimum to the maximum address. Okay. Now, this is the case when your all address lines are connected directly from memory microcontroller to the memory chip. Fine. Then we get that this is the address line. Okay. However, what about this case where we have seen this case where we have seen that A0 to A9 is connected directly. Okay, these are directly connected here. These are directly connected. These are directly connected. Okay, directly connected. And these unused address lines, are connected to address decoder circuit, and the output of decoder circuit is connected as CS to the CS input line. So can we find the range of address here? Can we find the range of address for this case? So let us try to find the range of address. Okay, for that purpose, I will write all the address lines okay here. So okay, here only. So since I've written all address lines here, A not to A12, so I'll use this case. Okay, let's use this one. Now, when you are going to write the range of address, okay, so in that case, you have to see that how many buses are directly connected. Okay, you just segregate into these two parts. A0 to A9, you can see A0 to A9, they are directly connected. Okay, so If you recall the address lines which are directly connected, for that case, the range of address will be all zeros to all the ones. Okay, so here I'm going to write the starting address. Starting address. So it will be 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Okay, likewise for the next address it will be 0, 0, 0, 1 and so on. 0, 0, 0, 0, 0, 0, 0, 1. Likewise next address will be 0, 0, 0, 1, 0. Okay, and so on. The last address, for the last address it will be all the ones 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this is varying from all the zeros to all the ones. Okay, but for the case we sir only 5 10 minutes. So for this case is now please see here for this. So these address lines, which are actually connected as input to this address decoder or gate, if you see, they all are fixed to zeros. Okay, they all are fixed to zeros because the output of OR gate is supposed to be zero. Okay, so I know irrespective of A0 to A10, which are varying from all zeros to all ones, these are supposed to be fixed to zero. Otherwise, chip selection will not be complete. So A11, 10, 11, 12, 13, 14, 15, they are fixed. They are fixed to zero. Okay, for either first address or the next address or the last address, they will remain fixed to zero. So that is 1, 2, 3, 4, 5, 6. Okay, so they are fixed. Okay, so this is not going to change. This will be fixed, but these will be varied. So now when you are calculating the address, that is complete address, so in that case you will have to see this whole A0 to A12. Okay, so see here A0 to A12. The starting address is, you can see this is 12340, then 12340, 12340, 12340. So I can say starting address is this one. Okay. Similarly, the end address will be 1, 2, 3, 4. This is 0 in hexadecimal. Then 0, double 0, double 1 is D in hexadecimal. Then this 4 ones is F. This 4 1 is F. So I got the last address as 0, T, F, F, H. Okay, this is the range of address. In between the intermediate values we are not interested to find. Okay, so this was the concept where we have seen that if I connect the full memory chip capacity, that is if I connect 64 kilobytes, okay, then the range of address will be 000h to FFFFH. Okay, this is the range of address when I'm connecting the full memory chip capacity. However, if the memory chip capacity is lesser than this one, then there will be unused address lines which will be connected as input to the address decoder circuit, and the output of address decoder circuit will be used for the chip selection. Okay. Now, in our 8051 microcontroller, there are something that we have already discussed. Okay, that was on-chip memory and off-chip memory. So let us discuss here the memory chip. Okay, discuss the memory chip. So we have two types of chip. One is called memory, on-chip memory, internal memory, and another one is called off-chip memory. Off-chip memory, which is called external memory. Okay. So on-chip memory is that memory which is there in 8051 microcontroller itself. Okay. So we have this 8051 IC. Okay. So on-chip, okay, there is on-chip ROM, okay, which whose capacity is 4 kilobytes. This is on-chip ROM. And then we have we know there is also on-chip RAM that we have studied. Okay, on-chip RAM whose capacity is 128 byte. Okay. These both ROM and RAM are on chip. Okay. However, we know that these are also not sufficient in many occasions. Okay, so what we do is we have to connect external memory external ROM and RAM. So this external ROM will be of 64 kilobyte capacity. Similarly, when we connect this external RAM, this is also 64 kilobyte capacity. Okay. Now there is difference that how the microcontroller will know that it is accessing the data of on-chip memory or off-chip memory. So for this purpose, there is a pin in the microcontroller which is called EA. EA. Okay. So when this EA, okay, how it is differentiable? See, we connect this EA to either VCC, okay, VCC. So this VCC, or we connect this to ground. Okay, we connect this to ground. So when remember that if EA is connected to ground, okay, that is actually called binary zero. So in that case, external memory external memory will be accessed by the microcontroller. Okay, and if EA pin is connected to VCC, that is you can say binary one, then it is internal memory chip. Internal memory will be accessed by microcontroller. Okay, so you have to remember this. Okay, uh, then there is something more that you have to understand. One more thing is there. In this, we have read pin and write pin. Okay. Now you know that these pins are used to read or write data. Okay, from the memory or into the memory. Fine. So in this case, you have to remember that when this internal memory chip is actually connected, okay, then when this microcontroller is accessing the internal memory, then this memory chip is having all two pins. Okay, that is called output enabled, and one more thing is there, which is called write enable. Okay, WE, write enable. So output enable means this output enable is connected with uh, RD pin, RD pin. Okay, this OE is connected with RD pin. This WE is connected with WR pin. Okay, so when the microcontroller wants to read something, okay, similarly here also we have that one. Okay, that is in this because it is okay. So not here. One thing you have to remember this is ROM. No, so from the ROM it is going to only do the read operation. So this write will not be there. Okay, so let us denote this. Okay, and in this case this is RAM. So for the RAM, this RD will be connected with OE pin, and this WR, that is called write pin, is connected with write enable pin of your on chip RAM. So, but there is one more thing that when the Memory chip is going to read something from this external memory. Then we have another pin here which is called PSEN, RAM store enable. This PSEN is connected with this OE pin. Okay, OE pin is output enable of your external ROM. Okay, so OE pin of your external ROM is connected with PSEN pin. Okay, ROM store enable, and then your read and write can be done. I mean, read operation can be performed with external ROM. Okay. Similarly, here also this is your RAM. So RAM is something that for which your this write will be also there. So this write pin is connected with your write enable pin. Okay. And this PSCN, not PSCN, RD. RD is connected with output enable pin. Okay, so this is so from here we'll discuss the next concept in the next class. Okay, we'll see some examples. Okay, that will be the last part of your memory interfacing. So this memory interfacing is little bit lengthy topic. So we will take three lecture for this one. First two lectures we have covered. The next lecture will be some numerical example. We will try to understand that how actually the 8051 microcontroller is interfaced using this PSEN, PN, and RDWRP, and we'll see some examples. Thank you everyone.